Hello viewers, I am Kausalya. Today we are going to discuss about problem 21. The problem is determine whether the system described by the state equation is completely state controllable. So here they didn't mention to use which method to find whether the system is state controllable. Either you can use Kalman's test or you can use Gilbert's test. Now in this video we are going to use these two tests and finally we are going to say whether the system is state controllable or not. Right. So from the problem it is clear, right? This is your A matrix and this is your B matrix. So initially we are stepping up with Kalman's test. So this is your A matrix and this is your B matrix. So in Kalman's test, what is the necessity is here we have to find the value of matrices AB and A square B, right? Because this is a 3 by 3 matrix. Therefore, our Kalman's matrix should also consist of a 3 by 3. That is 3 rows and 3 columns. It should be a 3 by 3 matrix again, right? So here the first thing is we are calculating the value of AB, right? Simple matrix multiplication and this is your answer. And the next step is we need to calculate A square B. So here I am calculating A square, that is A multiplied with A, that gives you the answer of A square, right? Now we are proceeding to A square B. So this is your value of A square and this is your B matrix. So when you multiply, finally we are ending up with the A square B matrix, right? So now finally we have the value of B matrix, AB matrix and A square B matrix. Now we are going to substitute these values accordingly. So here the composite matrix is given by B, AB and A square B, right? So now we are going to substitute the values. The value of B matrix is 0, 0, 1. AB is 0, 1, minus 3 and A square B is 1, minus 3 and 7, right? Next, we have to calculate the determinant of QC. So, the determinant of value is, it is equal to minus 1 here. Anyway, it is not equal to 0, right? So, then again, the rank of matrix QC is equal to 3 here. And therefore, the system is said to be completely controllable, right? So, regarding Kalman's test, it is very easy. Once you know matrix multiplication, everything is done here, right? Now we are proceeding to Gilbert's test. Just in order to give a clarity, I am solving, that is I am using these two test methods, okay, both Kalman's as well as Gilbert's. Whereas in exam, if it is asked simply to just tell whether the system is state controllable, you can use any one method, okay. It is better to go with Kalman's test because it is quite simple. Now we are proceeding with Gilbert's test. So for Gilbert's test, the first thing is we have to calculate the eigenvalues, right? So how to calculate eigenvalues? We have to find the determinant of the matrix lambda I minus A. So first we are calculating lambda I minus A here. So here lambda, right? Identity matrix. Here the A matrix is a 3 by 3 matrix. Therefore, we are selecting I matrix as a 3 by 3 matrix accordingly, right? So lambda I minus A. So when you just do subtraction, here we are getting the answer like this, right? That is 1 into lambda is lambda. So lambda minus 0 is lambda here. 0 minus 1 is minus 1 and 0 minus 0 is again 0, right? So just do the calculation like this. The next thing is we are going to calculate the determinant of this matrix, right? How to calculate the determinant? As usual, here the first element is lambda, right? So this lambda we have to leave this row and this column, and here lambda into lambda plus 3 minus of 2 into minus 1. So that becomes plus 2 here, right? So once you multiply, finally we are ending up with lambda cube plus 3 lambda square plus 2 lambda. We have to calculate eigenvalues, right? So here again I am taking this lambda commonly outside. So when you take lambda commonly outside, the remaining terms are lambda square plus 3 lambda plus 2, right? Again, when you find factors for this quadratic equation, here we are getting the answer as lambda into lambda plus 1 into lambda plus 2. So here the eigenvalues are lambda equal to 0 and the next eigenvalue is minus 1, the next one is minus 2. Right. So now these eigenvalues are totally different, right? So now we are going to the method known as van der Monde matrix. So this is a matrix which has values like this. That is, the first row consists of all ones and second row has simply eigenvalues and the third row has square of the eigenvalues. Right. So here again the value of lambda 1 is 0, lambda 2 is minus 1, lambda 3 is minus 2. And just take the squares and write down their respective values here, right? And the next step is we have to calculate the M inverse. M inverse is nothing but adjoint of M divided by determinant of M. So how to calculate adjoint of M? Initially we have to find the cofactors for all the elements which are present in the M matrix. Right. So before proceeding with cofactors, these are all the different sign values we have to consider. Right. Plus, minus, plus, minus, plus, minus, and again plus, minus, plus. Right. So first consider this one. We are going to find the cofactor of this one. So here we have to consider the plus sign. So how to find cofactors? You have to leave this row and this column and you have to consider the rest of the 4 elements. Here minus 1, minus 2, 1 and 4. Right. This is what I had written here, plus sign with this value. So when you multiply, minus 1 into 4 gives minus 4 and again minus of 1 into minus 2 gives you plus 2, so which is equal to minus 2 here. So the next thing is again we are going to find the cofactor for this one. So you have to leave this column, right, and you have to leave this row. So the remaining terms are 0, minus 2 and 0 and minus 4, right. So here it is 0. Similarly, like the same way, you have to find the cofactors for each and every term present in that matrix. Right. Again for 1 it is 0. And again for 0, just always keep it in mind. Though the number is 0, it will have some cofactors. Don't just blindly, if you got the number as 0, don't finally end the answer with 0. Right. So if it is 0, you see, consider this 0. Okay. So we will leave this row and this column. So what are all the remaining elements? 1, 1, 1, 4. Right. So it has a cofactor. Even for the number 0, there is a cofactor. So be careful while calculating with zeros. Right. Similarly, just do it for minus 1, minus 2 and again for the third row. Here the third row has elements 0, 1 and finally 4. Okay. Always keep in mind you have to include these signs. Okay. Whenever the signs are not included, then the answer won't be correct. So just take twice if you are calculating the cofactors. Right. So here the next thing is we are calculating the determinant of the matrix M. Right. Once the determinant value is calculated, it is equal to, you see, minus 2. Next, we are going to find M inverse. So it is adjoint of M divided by determinant of M. So this is your, that is the value of cofactors of the respective M matrix. Here we have to take a transpose, right? Then only we will be getting adjoint of M. So divided by, here the determinant of M is, it is minus 2, right? So now here we are proceeding with a transpose. So what is meant by transpose? Rows are converted into columns here. That's it. So here you see minus 2, 0, 0. This row becomes this column. And similarly this row becomes second column and this row becomes your third column. Right. The next thing is we are calculating B cap. So B cap is given by M inverse of B. Right. So this is your M inverse and this M inverse gets multiplied with this B matrix. So when you multiply here, we are ending up with the answer like this, right? 1 by 2 minus 1 and again 1 by 2. And the next step is we are going to calculate M inverse A M, right? So this is your M inverse and this is your M inverse and this is your A and this is your M. right? So first multiply these two matrices, and here we are ending up with the answer like this, right? The next step is we are going to multiply these two matrices. So here we are doing a matrix multiplication. I hope you people are familiar in doing this, right? And the next thing is we are simplifying, right? After simplifying, we have to divide this matrix by this minus 2. So here finally we are ending up with a matrix like this. So just write it in the general format. So it is given by z dot is equal to the respective final value of the matrix, right? M inverse of AM multiplied by z1, z2, z3 plus the respective values of B cap, which is multiplied by U here, right? So here when you observe at the final standard format, here the elements of B cap, you see no zeros are present, right? Therefore the system is said to be completely controllable, right? So finally, to end up with, in both Kalman's test as well as Gilbert's test, the final answer is same, right? That is, the system is completely controllable. So in the question, if it is generally asked, kindly go with Kalman's test, right? So here comes the end of the problem. If you have any doubt, let me know in the comment section. Thank you.